Now we see the third example in the miscellaneous exercise, that is the obtain the differential equation by eliminating the arbitrary constant of the following equations. Now the first example, y is equal to, it is a y square. Y square is equal to a into b minus x into b plus x. Now it is a given equation. We want to find the differential equation by eliminating the arbitrary constants. Now here the a and b, there are the two arbitrary constants. A and b are the two arbitrary constants. So from the differential equation we differentiate two times. Okay. Here it is a and this b. There are the two arbitrary constants. Therefore the given equation is, it is y square is equal to a into b minus x into b plus x. Okay, see carefully this. Now we can write it is a y square is equal to a into, it is a b minus x and it is a b plus x. We can write it is a b square minus x square. Okay, b square minus x square. Now there are the two arbitrary constants. We differentiate this equation two times. Now first the differentiate with respect to x. Derivative of y square with respect to x, it is a 2y dy by dx is equal to a constant as it is into derivative of b square minus x square, it is a 0 minus 2x square, it is a 2x. Derivative of the x square, it is a 2x, and then this can be written minus 2ax, and then this 2 and this 2 get cancelled. We get y dy by dx is equal to 2 get cancel, it is a minus ax. Now when we differentiate this equation, we get this relation y, it is y dy by dx is equal to minus ax. Okay, here now again it is arbitrary constant. To remove this arbitrary constant, again differentiate. Okay, therefore it is differentiate with respect to x. Differentiate with respect to x. Here first it is a given relation, we differentiate, we get this y into dy by dx is equal to minus ax. We get it is equation number 1. Now differentiate with respect to x. Here u into v, differentiate with respect to x. It is a product of two functions, it is a y and dy by dx. Therefore first as it is, derivative of the second function plus second as it is, derivative of the first. Okay. First as it is, derivative of the second, then second as it is, derivative of the first, that is the derivative of the y, it is dy by dx, and is equal to only minus a. Derivative of the minus ax is equal to minus a. Now again here in this given equation there are the two arbitrary constants, so we differentiate only two times. Here differentiate it is the first and here differentiate second time, but here again it is an arbitrary constant present. Now put the arbitrary constant value, it is a. Okay, here it is a minus a. Then from the equation 1 we get minus a is equal to, we take x here, y by x dy by dx. Therefore we can write y d2y by dx2 plus dy by dx whole square is equal to, it is y by x dy by dx by 1. See carefully this. We put the value of the minus a. Minus a is equal to x. We write in the denominator of y. Y by x dy by dx is equal to minus a. Put the value of the minus a. And now multiply by x here. We get xy d2y by dx2 plus x dy by dx square is equal to y dy by dx. And last we can write xy d2y by dx2 plus x dy by dx whole square minus y dy by dx is equal to 0 is a required differential equation. See carefully this. Now we see the second example. Second example is y is equal to a into sine of x plus b. Here again there are the two arbitrary constants a and b. The given relation y is equal to a into sine of x plus b. Okay. Now differentiate with respect to x. Differentiate with respect to x. The derivative of y, it is a dy by dx is equal to a into derivative of sine x plus b, it is cos of x plus b, and into derivative of x plus b, it is 1 plus 0. Okay. That means dy by dx is equal to a into cos of x plus b only. Again differentiate. Derivative of the dy by dx, it is a d2y by dx2 is equal to a into derivative of the cos x plus b, that is the derivative of cos x, it is a minus sine of x plus b, and into derivative of the x plus b, it is a 1 plus 0, that means 1. Okay. Here we write into derivative of x plus b, that is a 0, and then d2y by dx2 is equal to minus a sine x plus b. A sine x plus b, we take it is given, it is equation number 1, it is y by 1, and therefore last answer d2y by dx2 plus y is equal to 0 is required differential equation. Okay, see carefully. Here it is y is equal to a into sine x plus b. There are the two arbitrary constants, so we differentiate two times. Now the next third example. Y minus a whole square is equal to b into x plus 4. Here the given y minus a whole square is equal to b into x plus 4. Okay, see carefully this. Now there are two arbitrary constants, so we differentiate two times. Okay, yeah, differentiate with respect to x. The derivative of y minus a whole square, it is 2 into y minus a into dy by dx is equal to b into 1 plus 0. See carefully this, and therefore it is a 2 into y minus a dy by dx is equal to b. See carefully. When we differentiate one time, there are the two arbitrary constants are present. It is a and b. That means we does not eliminate any constant. Okay, it is a and b. Now here it is a b. from this given relation, here the value of this b, it is a y minus a square upon x plus 4. See carefully this. Therefore 2 into y minus a dy by dx is equal to, it is b, it is a y minus a square upon x plus 4 by 1. Okay, here b is equal to y minus a whole square upon x plus 4. Now here now there are only one arbitrary constant present, that is a. Now it is y minus a, and here it is y minus a square. Y minus a get cancelled. Then we get 2 dy by dx is equal to y minus a upon x plus 4, and therefore it is 2 into x plus 4 dy by dx is equal to y minus a, this y minus a. And now when we differentiate this relation, this a get cancelled, okay, because it is a constant, it is minus a get cancelled, and then we get our differential equation. Therefore again differentiate with respect to x. Now here 2 as it is x plus 4 into dy by dx. Here we use the u into v. Then 2 as it is. First function as it is, derivative of the second, it is d2i by dx2 plus second as it is, derivative of the first function, that is 1 plus 0, derivative of x it is 1 and derivative of 4 it is a 0, is equal to dy by dx minus 0. Here 2 as it is, u into v, we find the derivative of this two function, and here derivative of y it is a dy by dx, and derivative of a it is a 0. And now only we simplify this. Here 2 into x plus 4 d2i by dx2 plus 2 dy by dx. Here we multiply by 2, it is dy by dx, and here dy by dx we can write is equal to dy by dx. And now the last answer, 2 into x plus 4 d2i by dx2 plus dy by dx is equal to 0. We write this dy by dx here, that is minus 2 dy by dx minus dy by dx, it is a dy by dx, and here is required differential equation. Okay, see carefully this. Again there are the two arbitrary constants, we differentiate 2 times. Yeah. Now the next, the example number 4. Y is equal to under root of a into cos of log x and plus b into sin of log x. Here. Now such type of the example we have already learned in our exercise 2, but there only give y is equal to without under root, a cos log x plus b sin of log x. Okay, but here it is under root. Then given y is equal to under root of a cos of log x plus b sin of log x. Then squaring on both sides, y square is equal to a into cos of log x plus b into sin of log x. Okay. Now there are the two arbitrary constants, we differentiate 2 times. Therefore differentiate with respect to x. The derivative of y, it is a 2 2y dy by dx is equal to minus a into sine of log x into derivative of log x, it is 1 by x, plus b into sine of log x, the derivative of sine of log x, it is a cos of log x into 1 by x. Now here this x, it is we can write here 2xy dy by dx is equal to minus a sine of log x plus b cos of log x. Okay. Now again differentiate this with respect to x. Differentiate with respect to x. Now here it is a 2 into, but here x into y into dy by dx. There are the three functions in the product. So here we use u into v into w. Okay. Here u into v into w, or we take x into y is a one function, that is the, here we take x into y is equal to u and dy by dx is equal to v. Okay. We can use both methods. It is u into v. When we use u into v, we take x into y is equal to u and it is v, or we use u into v into w. Okay. Here we use u into v. We take this is u in x into y, it is a u, and dy by dx is equal to v, and use the rule for the product. It is a derivative of u into v, v into derivative of u plus u into derivative of v. Okay. Now differentiate with respect to x. It is a 2 as it is. Here first function as it is into derivative of the second function. Okay. Here derivative of the second function, it is dy by dx plus second function as it is into derivative of the first function. It is derivative of x into y. See carefully this. 2 as it is u and it is v. First as it is derivative of second, then second as it is derivative of first, and is equal to the derivative of this function. The minus sine of log x, we can write here minus a cos of log x into 1 by x plus derivative of cos of log x, it is a minus sign, so you can write minus b into sine of log x into 1 by x. Okay. Now see carefully. First find the derivative of this term. Therefore it is a 2 into xy d2y by dx2 plus, it is xy d2y by dx2 plus dy by dx into the derivative of x into y, again here u into v. First as it is derivative of the second plus second as it is derivative of the first, and is equal to, this is as it is, minus a cos of log x into 1 by x minus b sine of log x into 1 by x. Okay. Now throughout multiplying by 1 by x, sorry, it is x, here it is 1 by x, throughout multiplying by x, this 1 by x, it is x get cancelled, and here multiply by x. Therefore we write here multiply by x. Then we get this 2x into the bracket as it is xy d2y by dx2 plus x dy by dx square, x into dy by dx square plus y into dy by dx. Only we multiply by x. Here we write x. It is only 2. Here we write the 2x. And this RHS becomes, it is a minus a cos of log x and minus b sine of log x See carefully this x, when we multiply by x, this x and this x get cancelled, and now here the remaining term, it is a cos of log x minus b sin of log x. We take the minus common in this, then it is right this, and here it is our y square. Okay. And therefore we multiply this 2 x square y d2y by dx2 plus 2x square dy by dx whole square plus xy dy by dx is equal to minus y square. It is a minus y square. Okay. And now the last answer, 2x square y d2y by dx2 plus 2x square dy by dx whole square plus xy dy by dx and plus y square is equal to 0, and it is a required differential equation. Is required differential equation. See carefully this. Here we take x into y as a u and dy by dx, it is a v, and then we use the derivative of u into v, u into derivative of phi plus phi into derivative of u. See carefully this. Now the last example in this question. Y is equal to a into e to the power 3x plus 1 plus b into e to the power minus 3x plus 1. Okay. Again here there are the two arbitrary constants a and b. We eliminate this arbitrary constant by using the differentiation plus. Okay, now differentiate with respect to x. The derivative of y, it is a dy by dx is equal to derivative of this term a as it is into e to the power 3x plus 1 into 3. It is a derivative of 3x plus 1 plus b into e to the power minus 3x plus 1 into minus 3. Minus 3, it is a derivative of e to the power 3x, and then dy by dx is equal to, here it is a 3a into e to the power 3x plus 1 minus 3b e to the power minus 3x plus 1. Again differentiate. Differentiate with respect to x. The derivative of dy by dx, it is d2y by dx2 is equal to 3a, it is a constant as it is, derivative of this e to the power 3x plus 1 into 3 plus, sorry, it is minus 3b as it is, the derivative of e to the power minus 3x plus 1, it is e to the power minus 3x plus 1 into minus 3. And now here 3 into 3, it is a 9. Here see carefully, we take this 9 and again here minus 3, again here it is a 9. Okay, we take 9 common, then we get a into e to the power 3x plus 1 and here plus b into e to the power minus 3x plus 1. Okay, see carefully this. It is a 3 into 3, it is 9, and here it is a minus 3 into minus 3, it is a plus 9. We take this 9 common, then remaining a into e to the power 3x plus 1 and here plus b into e to the power 3x plus 1. And now we know that it is a 9 into y. this. It is a d2i by dx2, and therefore the last answer d2i by dx2 minus 9y is equal to 0 is required differential equation. Okay. See carefully. It is the last example in the question number 3. Formation of the differential equation by eliminating arbitrary constant. See carefully this.